Okay, today lesson 7.4, approximating square roots. A rational number is a number that can be written as the ratio of two integers. An irrational number cannot be written as the ratio of two integers. So when we're talking about a ratio of two integers, we're talking about something as simple as this, just a fraction, right? So all fractions are rational numbers. Some of them can be simplified, and they will be a decimal. If they are in decimal form, to be rational, they are repeating or terminating. Irrational numbers are non-terminating and non-repeating. So, we have basically two main classifications, rational and irrational. Rational numbers, picture the number line. It is all of the values on there. All of the whole numbers, natural numbers, integers, and everything in between, right? All those decimal points that we could literally put on the number line. The irrational numbers can't, because they never quite terminate or repeat enough for us to put a point down on the number line. Okay, this is just a very general, vague description. Think of the number pi, right? We know that that is a very famous non-terminating, non-repeating number that is irrational. It also states here that the square root of any whole number that is not a perfect square is irrational, and the cube root of every integer that is not a perfect cube is irrational. So if you cannot simplify the square root or the cube root to be an integer, then it is irrational. And so you'll be classifying several numbers. The next slide is a great visual aid. It's in your book. You could find this and look at this or copy it down in your notes. Rational numbers and irrational numbers together form the set of real numbers. So when we're classifying, we want to list every subset that the number would belong to. So on the left side of rational numbers, the innermost circle is natural. So the natural numbers, like 1, 2, and 3, are also sometimes called counting numbers. You first learned about these in kindergarten. These are the first sets of numbers you came into contact with. Then when you included 0, it became the set of whole numbers. So the whole numbers are the natural numbers plus 0. The integers then are the whole numbers and their opposites. And then the rational numbers are all the numbers in between, all of the decimal values that will terminate and repeat. The irrationals on the right in the blue circle are all the ones that will not terminate, repeat, all the square and cube roots of non-perfect squares or perfect cube numbers, and obviously anything that includes the number of pi. So if we classify each real number in the left column, A, B, C, D, and E, in the subsets, and we can give reasons why. So for the square root of 12, it is an irrational number, and the reason is because it is not a perfect square. 12 is not a perfect square. For the negative 25 repeating is a rational number because it is a repeating decimal. The opposite of the square root of 9 is negative 3. Therefore, it is an integer and a rational number because it is equal to negative 3. 72 over 4 is in ratio form. So already we know it's a rational number. When you simplify it, because you get the number 18, it is a natural number, a whole number, an integer, and a rational. It is a part of all of them because it is equal to 18. And pi is irrational because it never terminates or repeats. So let's classify the numbers. The first one is irrational. And the reason it's irrational is because it never terminates and it does not repeat. Even though it forms a pattern, it's not a repeating pattern of the same thing. For number 2, it simplifies to a negative 14. A negative 14 is an integer and a rational number. The cube root of 2 is irrational because it is not a perfect cube. So approximating square roots. And this is an example right out of your book, example 2. Mainly, the most important thing is right here, is this understanding of where the number falls. So when you're talking about the square root of 71, we know that, between two perfect squares, 64 and 81, is between 8 and 9 on the number line. So when you try to decide, is 71 closer to 8 or closer to 9, look at how close 71 is to 64. Okay? And look at how close it is to 81. We know that it's about 10 numbers away from 81, but it's only about 7 numbers away from 64. Therefore, it's closer to 8, so you would approximate it to be about 8. When we get to this section, the actual making a table of the decimals, I'm fine if you put 71 in your calculator and use the square root button. Here, it comes into rounding because this is going to go, on and on and on. And since you're rounding to the 10th place, it's one place to the right of the decimal. You circle that number, look to the right of that. So we would round to 8.4 because the 2 does not round it up to the 8.5. So today you'll be asked to round to the nearest integer and to the nearest tenth. So you'll be given 2 answers. Okay? So let's try some of these. Okay, so when you look at the number line for this one, we're going to have the number 2 and the number 3 because we have the square root of 4 and the square root of 9. And you know that the square root of 8 is between these, and since it's closer to 9 for part A, the integer, it is approximately equal to 3. When we put the square root of 8 in our calculator, the answer to part B, to the 10th place, is going to be 2.8. Okay? For 5, because it is the negative square root of 13, we are looking at possibly between the negative 2 and the negative 3 on the number line. Right? So, wrong. Between the negative 4, sorry about that. Negative 4 and negative 3. That's what I meant to do. Because this would be 16, and this would be square root of 9. And this square root of 13 is going to be closer to the 16, so for part A, we're going to say approximately 4, because 13 is only 3 numbers away from 16, but it is 4 numbers away from 9. And when we put it into the calculator, we will see that it is actually, and it's negative 4, too. It is actually, for the decimal, negative 3.6 to the 10th place. Okay? For 6, again, we're working on, so on the number line, we would have a negative 5 and a negative 4. This would be opposite of the square root of 25. And this is the square root of 16, the opposite value. And so this negative root of 24 is only one number away from the 25, so it is approximately closer to a negative 5. And when we actually evaluate it, it rounds to negative 4.9. Back to the positive side here, we've got between 10 and 11, square root of 100, square root of 121, and the square root of 110 falls between them. It's 10 numbers away from 100, and it is 11 numbers away from 121. So for part A, it's approximately equal to 10, and part B, believe it or not, rounds to 10.5. So just use your logic there that it's going to fall right in the middle. So if you're just looking at 10.5, how would you know if it's closer to 10 or closer to 11? Well, look at the original value. 110 is 10 numbers away from 100, but 11 numbers away from 121. Therefore, it's closer to 100, or approximately 10 for part A. So definitely use that logic and that thinking. Okay, so in this case, we're going to be telling which is greater, the square root of 5 or 2 2/3. Again, estimating it to the nearest integer and then graphing the numbers on the number line. So the square root of 5 is approximately 2, and then this 2 2/3 is about 2.6 repeating. So since 2.6 repeating falls to the right of the square root of 5 or falls to the right of 2, then 2 2/3 is greater. So that's kind of how we're going to be evaluating these. So when we have 4 1/5, you could change these to decimals. So 4 1/5 as a decimal is 4.2. And the square root of 23 is about 4.8. Therefore, the square root of 23 is greater, right? Because it falls to the right. And it is asking you to explain. So when you graph them on a number line, it falls to the right. Looking at 9, you have the square root of 10 or the opposite or negative value of the square root of 5. The square root of 10 is going to be a positive value. If this is positive, this is negative. We know that the square root of 10 is greater because all positive numbers are greater than negative numbers. Okay, so we really didn't even have to graph that one. Looking at the number 10, the square root of 2, we want the opposite of that, and negative 2. So again, looking at the number line here, we know we have a negative 2, negative 1, 0, and that square root of 2 is somewhere between the square root of 1 and the square root of 4, right? And negative 2 is definitely right here. So this square root of 2, the opposite of square root of 2, is going to fall somewhere, in between here. So the opposite of the square root of 2 is greater because it falls to the right. On the number line. So it is to the right on the number line.